Hello everyone, I'm Isaac. I want to show us how we can make use of logistic regression model, precisely binary logistic regression, in analyzing adoption of farm technologies. So I want to open Stata for us to see what I'm talking about. This is Stata here. So when do we use logistic regression? Logistic regression is used when we have categorical response variable. So binary logistic regression talk about having two level or two categories as our response variable. So whenever the response variable is having two level or two categories, we make use of binary logistic regression. When it is more than two level or two categories, we're going to make use of multinomial logistic regression. I have a data here. This data is on it's about farmers. Certain farm technologies was introduced to them. So what we have here is that some of them adopted it, some did not adopt it. So those that adopted it is coded as 1. Those that do not, coded as 0. These are their ages and these are the farm size. 10 acres, 15 acres, and so on. Pest incidents indicate number of times that they experience pest incidents on their farm. This farmer, the first farmer, for farmer ID 1 has 3 times, 1 time, 0 time. So now I want to see the factors that contribute to whether they are going to adopt the farm technology or they are not going to adopt it. So I'm going to make use of age and farm size as independent variable. They are the factors that determine whether they are going to adopt it or not. So all I need just to do is just to copy this data. Copy the data. And now open my data editor in Stata. Paste it. I want to make my row as my variable name. Yes. Okay. So there are 2 ways you can go about analyzing this data using logistic regression. I can use my command. Command is just logistic. Then my response variable is adoption, independent variable age, and farm size. I will just enter it. So this is my result. So you can see the result, the odd ratio. The odd ratio is talking about the odds of adopting this depending on the age, C, and farm size. So we want to see which one that contributes most, which one here has tendency of determining whether a farmer is going to adopt the farm technology or not. So you can see 0.98 is higher than 0.87. So farm size seems to be the one that determines whether the farmer is going to adopt it more than each. Each also contributes. They are all very low, 0.6. That's why the p-value is, the p-values are very high. So none of them is significant anyway. Look at the number of observation here, 10. Then the likelihood ratio is here, that 2.06. P-value is 0.35. Then the pseudo R square is here. So now if I want, instead of having odd ratio here, if I want to have the coefficient, what I need to do is just bring the code back. I'll just write coefficient. Coefficient, just enter it. That's change. You can see what we have here. You can see the values here. They are all very low. So you can see here, but the p-value do not change. And no observation or the rest do not change. So all you need to do is just to interpret this. Now if you want to go through windows, just come here, statistics, go to linear binary outcomes, pick logistic regression, now see dialog box. You can see logistic regression reporting odds ratio. So we can see pick adoption as our dependent variable. Independent variable, we are picking age and farm size. Then can just check all of these. One that's familiar, relevant with what we are doing. I'm going to check them. Then you okay. So we have gotten the same result. You can see. One beautiful thing about Stata is that even the code will be generated. You can see it here. So the next video I'm going to make use of how we can make use of Poisson regression. So watch out for the next video. Thanks for listening.